Good day, my wonderful viewers out there. Today, in physics, we shall be looking at fundamentals and derived dimensions of quantities. Now, before we talk about this very topic, there is need for us to understand what a fundamental quantity is and what a derived quantity is. Now, a fundamental quantities are those basic quantities that without them some other quantities in physics cannot function effectively. And a good example of such fundamental quantity are, we have examples of fundamental quantities. We have mass, we have length, and we have time. We have number of moles, and electric current. Now, all these electric current and etc. etc. All these are all fundamental quantities. But the basic quantities that we have are the mass, the length, and the time. And all this has the dimension as the dimension for the mass is m, dimension for the length is L, and dimension for the time is T. So these are basic what? Dimensions. We call these basic dimensions in physics. These basic dimensions are quantities that forms the fundamentals of physics, and that is why we refer to them as independent quantities. They are independent in the sense that they don't need the assistance of any other quantity in order for them to exist. So in the case of the derived quantity, we have examples of derived quantity. Examples of derived quantity are, we have the force, we have the area, we have the speed, we have velocity, and etc. All these are examples of derived quantity. Now, how do we form some of the dimensions of the derived quantities? So we'll have the derived quantities and the various dimensions. And first, let us start with the area. Now, area is defined as length times breadth. Defined as length times breadth. If you watch, both length and breadth are all measurement of space, and that space has to do with what? With distance. And the dimension for measurement of distance is both what? L times what? L. So we say therefore dimension for area is equals to L square. So this is dimension for area. Then we have the case of the speed. The speed. Now the speed is defined as in distance, change in distance all over time. So if speed is change in distance over time, remember speed is a derived quantity, because derived quantities are quantities that are dependent of what? The fundamental quantity. In other words, for them to exist, they need the presence of the fundamental quantity. So we'll say, therefore, for speed dimension will be equals to the dimension for distance is what? L. We have L over the dimension for time is what? Is t. As you can see here, we have t here. So say therefore dimension for speed is equal to, we have L times 1 over t. L times 1 over t. Now this 1 over t, we'll use the inverse of 1 over t. We'll say therefore speed is equals to L times t raised to the power of minus 1. Now if speed is equals to L times t raised to the power of minus 1, we'll say it's equals to LT raised to the power of minus 1. So this is the dimension of speed. So activity on your own, solve the various dimensions of the following quantities. Where we have A, we have force. Remember, force is mass times acceleration. We have B, we have density. Density is mass over volume. Then we have C, volume. So we are expected to solve this activity by solving for the various dimensions, and see you in our next class. Thank you very much for viewing to this channel.